First, we're going to need a fractured object. For that, we can use Blender. When we have an object that we want to fracture, go ahead and click the object, click F3, and then click Self Fracture. If Self Fracture isn't showing up here when you type it in, that means you need to enable it. To enable it, go to Edit, Preferences, Add-ons, and then type in Self Fracture. Check the box and then close the window. Once that's enabled, click your object, click F3, and then click Self Fracture. That's going to bring up this dialog box. Most of these default fields are fine. Make sure that noise is set to 1. That way you can get the most random fracture on your object. Once you're done setting your values, go ahead and click OK. That's going to create a bunch of cells based off of our base right here. And it even selects them for us, which makes it very convenient. From here, we're going to go to File, Export, and then click GLTF. Make sure that you're in your Godot project's game development folder. Click Include, make sure Selected Objects is checked, and then name it something that you're going to remember. For this, we're going to name mesh.sphere.glb. Click Export. Depending on the number of cells and the size of the object and the complexity, it could take a minute, but for this, it only took a second. We're going to go back to our Godot project. It exported here to mesh.glb. I'm going to click Alter, and then I'm going to drag it in. That way it makes it a child of the Alter spatial. Next, I'm going to put it on top of the pedestal. Adjust it like so. I'm going to click it and make local. That way we're going to have all of our meshes under the mesh sphere spatial. And in fact, I'm going to name this shards backup. That way we can have a backup of all of our shards just in case something goes wrong. From here, I'm going to click Alter and then Set Material. It's going to give all of these cells a nice red material, which isn't all that important, but it does look better. From here, I'm going to Shift left click all of these, copy, and then put them into the shard spatial. I'm going to hide the backup. And now, once we have all of our cells in the shard spatial, I'm going to click Alter once again, and then I'm going to click Create Rigids. And what that's going to do is create rigid bodies for the Godot physics server to actually work with, because Godot needs rigid bodies in order to apply the physics effects. And as you can see, the physics engine was currently running, so it shattered. But thankfully, we have a backup. So I'm going to go ahead and disable the physics server. I'm going to delete all of these rigid bodies. I'm going to go back into our backup. Shift select and paste. Now I'm going to go back to Alter and then click Create Rigids once again. Now, this time, they didn't shatter, and you can actually zoom in and see the fractures along the faces of the mesh, which is pretty cool. But as you can see here, our neat little script made things a lot easier for us, because otherwise we'd have to go mesh by mesh by mesh and put it in a rigid body and give that rigid body a collision shape, and it's just a big hassle. So I made a little script for it, and that script created this rigid body, put the mesh inside of it, and then gave it a collision shape. Now we can go back to Alter, and what I like to do is actually click this Get Shard Positions variable, and what that's going to do is basically put all of the shards positions and rotations in a dictionary. That way, it's really easy to reset the shards back into their original position. So if I click P, it'll enable it. If I click N, it's going to stop the physics server. And if I click Reset, it's going to put them all back in the same spots as they were when you clicked Get Shard Positions, which is actually kind of fun to do repeatedly. It also gives you an idea as to how the sphere or whatever object you're working with is going to break time and time again. Okay, I guess once that's done, we can get on to the scripts. Now this main script that's actually governing this is going to be attached to our alter. So when you're actually doing this with your own mesh, you're going to probably put this on the parent of that container that contains all of your rigid bodies. So in this case, shards is the container, and then alter is the parent of shards. Back to the script, we have a number of exported variables. We have our set material, which is actually what changed the material for all of the shards in the shard backup. Down here, we have the keys that enable and disable the physics server, key P and then key N. Get shard positions is what's actually run when we click get shard position. It takes the positions of all of the shards in their current position and then stores them as a just a 2-element array, and then it puts them into a little dictionary, which, as shown back on our world, is actually very useful in resetting our shards back into the original position. The reset function here basically is in charge of putting all the shards back into the original positions as per the dictionary, or the elements in the array per the dictionary item. The create rigids is actually what's creating the rigids for all the meshes that we have imported from Blender. So this basically parses through every single mesh that was added, the outer cell 1, outer cell 2, and create a rigid body for each of them. I know this looks rather complex, but we'll get through it. So first, the rigid body scene is loaded. We're going to go ahead and instance it as sRigid body. sRigid body will be given a translation, and that's basically going to be the translation of the mesh as established from the shards.getChildren array. From here, we're going to go ahead and set the scale as vector3 111, nothing special there. Shards, we're going to add the rigid body to the shard spatial container. We're going to set the rigid body as having the owner of the scene root that we just edited, and that way it'll actually show up in our shard spatial. Otherwise, the rigid bodies, even though they're being created, would not show up in our scene tree over here. So now we have a mesh node. We're going to go ahead and remove this node, which is back here, since we've just assigned the node to mesh node. We're going to put the mesh at translation 000, translation scale 111, and that basically takes this mesh and puts it back into its original position. And this time it's going to be put as a child of the rigid body, which can be seen right here. Now again, as we did for the rigid body, we're going to have to set the owner of the mesh node to the edited scene root, otherwise it will not show up in our scene tree. Now this is where it gets a little more complicated, but I've added some comments here that'll hopefully clarify some things. This line of code here is going to take our mesh node and create a convex collision shape. And what that basically is that it creates 2 additional nodes. It'll leave the mesh as is. It'll create a static body and put that as the child of the mesh. And then as a child of the static body, it'll add the collision shape. Now, we're going to want to grab that collision node by selecting mesh node, selecting the first child of the mesh node, and then selecting that child, which would be the collision node that we just created with create convex collision. Now that we have it selected, we're going to go ahead and remove it by using this little complicated piece of code. And then we're going to remove the static body that was the parent of that collision shape using this line. And finally, we're going to take the collision node and add it as a child of the rigid body, which will put it right here. So we have a rigid body, we have our cell, which is the first child, and then we have our collision shape, which is the second child of rigid body. And then of course we have to set the owner of the collision node to the edited scene root, or else it will not show up in our tree. And that's pretty much all there is to that. So when you're thinking about applying this to your own nodes and to your own objects in your scene tree, remember that these paths might need to be changed for that to work. But I'm sure that after some tinkering, you'll be able to handle that just fine. Well, thanks for watching. If you have any questions, please leave them in the comments. I'm going to put this entire project on my GitHub, and the link to that project will be in the description. Have a good day.